What's happening, guys? We're back. We're gonna weld together the steering shaft today. Alright guys, we are back. The goal today is to get essentially the entire steering column done, but really that lower section. That's the next major hurdle. We got the hole made in the chassis to accommodate it last week. So this week we need to build the shaft that's gonna go in there. I think I brushed over our steering shaft design in a previous episode. If I did, skip ahead. If I didn't, I'm gonna explain it real quick. So our entire steering shaft is made out of this 3/4 inch DD steering shaft stock and the appropriate knuckles. These are great because the DD steering shaft is the same profile through the entire length. So you can order a long section and then just cut it to whatever length you need, and the U-joints will slip right on. Versus the other method, which is spline shafts, where you order a shaft and it only has like 1 or 2 inches of spline on either end. So you gotta be pretty precise on your measurements. And we weren't very precise at all. So this works way better. The one problem with this is that there are only 2 ways that this shaft will go into the U-joint, and they're 180 degrees apart. So it makes it really easy for putting it all together, but the problem comes in when you go to drive your car away and your steering wheel's like this. There's no way to adjust that. You can pull one of those U-joints off and turn it 180 degrees, but then your steering wheel's like this. So you need kind of a fine adjustment to get your steering wheel to straighten out. So it's really good practice to always put a spline somewhere in the steering column. We're gonna use the stock Mazda steering box, and it already has a spline on it, so we're gonna use that. So this is the stock Mazda lowermost U-joint. It's 36 spline on one side and some weird metric 7/8 of something or another on the other side. So we need to adapt our 3/4 inch steering column to fit in there. It's pretty sloppy right now. Theoretically I could like machine a collar or a spacer. I could do something, but I think the best thing to do is we're just gonna use the stock steering shaft. So I went and cut the end off of the Mazda steering shaft so it'll fit in there no problem. We'll be able to reuse the same pin system, etc., etc. So now we just need to get this adapted over to our 3/4 inch DD steering column. So to do that, I took a chunk of the steering column and I machined down the end, because this has a slightly tighter ID, and now it just sits on there nicely. I would have liked to have gone further, but we're already actually a little bit tight for length, so that's as far as I could go. We could probably just weld this up and it'd be strong enough, but to add a little bit of extra strength, it is a steering component, so I want to be safe. I machined a little collar that actually slides over top of that joint. It's got a step on the ID. So what we'll do is we'll weld these 2 pieces together, and then I'm actually going to drill a couple holes in here so we can slide this collar over, seam weld both ends, as well as do a couple of rosette welds on either side. So that will be, honestly, that'll probably be the strongest part of the entire car. So we're gonna do that, and then drop that in there. We have our little Heim joint support thingy majiggy, so that'll go on here. We'll build a little bracket for that, and then we're basically done the bottom end. So it's gonna be a lot of welding, so let's do it. we got it all tacked together. Before I finish weld this sleeve on, I want to talk real quick about the rosette welds. We took this outer sleeve and drilled a couple holes in it, and that's for rosette welding or plug welding, depending on what side of the pond you're on. I like rosette welding, sounds classier. So what we're gonna do is we're actually gonna come into these little holes and weld the sleeve onto the pipe that's sitting underneath it all the way around that hole. And what that's gonna do for us is, rather than just having one weld holding onto each side, we're actually gonna have two welds spaced apart. So it'd be like trying to hold this shaft up from the end versus holding it up from 2 points. It's not nearly as critical on something like this where we have a weld in the middle, but if, say, we didn't have that weld in the middle, or we were trying to like sleeve onto one piece onto another piece of pipe where you don't have that stability all the way through, as soon as there's any amount of flex, if you only have one point of contact, it's really hard to stop that flex, versus if you have 2 points of contact, it's much more rigid. So if you do something like this and you have some flex and you don't rosette weld it, the two pieces will wiggle and then you'll get major stress cracking on the main circumferential weld and you'll end up failing it. So not a huge deal on something like this, which is only really gonna see torsional loads, but anything that's gonna see a bending load on it, make sure that you drill a couple holes, throw a couple rosette welds in it. So with that out of the way, let's finish weld this girl up. All right, after getting those all welded up, looks really good. We had to bump our amperage all the way up to 160 amps to do the rosette welds onto the solid bar, just to get enough heat into the solid material to get good fusion with the sleeve. So this thing's really hot right now. It'd be impossible to press the U-joint on or really test fit it in the car. I can barely hold on to it with my gloves. So I'm gonna let it cool off overnight and then catch up with you guys tomorrow. All right, we're back. We got a couple more hours in the shop tonight, so all things going in our favor, we should be essentially done the steering column by the end of this episode. So first thing we gotta do, we gotta get this the factory Mazda U-joint back onto the factory section of shaft. I wasn't thinking, I probably should have put that steering shaft into the deep freeze for a couple hours to try to cool it off, shrink it down a little bit, but I didn't. So we're gonna try it at room temperature, and if that doesn't work, we'll freeze it overnight and try it again in the morning. Once that's on, we can kind of mock it up, get our little Heim joint bracket built, and then pretty much done. So let's just crack into it. All right, steering shaft's done. It's in there. Everything looks really good. I got lots of clearance past my brake pedal and through kind of all the chassis areas. Yeah, so that's pretty much done. All we're gonna have to do now is cut this top section and weld that quick hub on. I'm not gonna do that right now though, because I wanna get kind of my seating position finalized and pick where I want that. Because once we cut that, we can always make it a little bit shorter by cutting more off of the U-joint end. We can't make it any longer, so we gotta make sure it's in the right spot. One thing I did notice after I had everything together, I made one huge mistake on this steering column and I can't fix it. So here, I'll show you. So one thing when you're building a steering column is to make sure all of your U-joints are clocked correctly. So on DD steering shaft, it's pretty easy. You can see this U-joint here is kind of clocked this way, if that makes sense. The forks are horizontal on this end, and then up on this end, I don't know if you're going to be able to see that, the forks are also horizontal, so those are in line. So on DD steering shaft, they always keep their U-joints in sync, it's called, because they're always, because you only put them in 180 degrees apart. But when I put this shaft together, you'll notice on this end, the forks are horizontal, and then up on this end, my forks are vertical. So this steering shaft is 90 degrees out of sync, which is the worst that you could possibly do it. Unfortunately, the only way to fix that is going to be to either re-drill this pin, which I don't want to do, or cut this sleeve off and rotate everything 90 degrees, which I definitely don't want to do. So I think we're just going to leave it like that for right now. We'll see how bad it is. The reason that you don't do that, the reason you want to make sure that those U-joints are synced up is when you turn the steering wheel, basically what happens is if they're not synced, when you turn the steering wheel, there'll be a lag and then it'll accelerate, and it'll kind of, the end point and the start point won't turn at the same rate. You can look it up online. There's way better explanations with graphs and sine curves and stuff, but long story short, you want to have your forks on your U-joints this way and that way, like they got to be in sync. So we're 90 degrees out on the bottom. Shit, it is what it is. I should have looked at that before. I'm kind of mad at myself. But the only way to fix it really is going to be to totally rebuild that lower shaft, which we were already talking about possibly doing once we get this car on the road. Rebuilding it without that welded joint in there and buying a proper DD to 36 spline lower U-joint. That would solve all of our problems. So we have a solution. We're not going to do it right now because it costs money. So with that in mind, we're going to call it an episode here, guys. Good progress. I have no idea what we're going to do next week, but that's next week Curtis's problem. So thank you so much for watching. If you haven't already, hit the like and subscribe button. Go check us out on Instagram, Left Foot First Media, and we'll see you next week. I'm out of here.